Okay, beta. Some general instructions which we follow before we attempt the chart work, before we open up the chart. So some of the things which you should keep in mind, especially when you are attempting a MMD paper. All the old lines markings from the chart should be erased before you start your work. There may be many markings along the latitude and longitude scales. You may have some markings on the compass rose. So all these should be erased so that there is no confusion in the mind of the invigilator regarding what you have done on the chart. We are supposed to use a 2B pencil. That's a soft pencil. It does not deteriorate the chart, and a good quality eraser. Use transparent plastic protractor and parallel rulers or set square. Whatever tools you are using, recommended that they should be transparent, so they do not hide or obscure any information which is under that tool. Okay, now some tips you can keep in mind for accuracy. Measure all the bearings and courses by using only the nearest compass rose. Avoid using the angle markings, which are sometimes given on the parallel ruler also. These angle markings are less accurate. Not that you cannot use them, but their accuracy being lesser, the variation in your answer may be little more. So use the nearest compass rose whenever you are measuring up any courses or bearings, because the more you move your parallel ruler or sliding ruler or set squares, the more error is what comes in. So try to use them for as short distance as possible. Always use or try to use the same edge of the parallel ruler when you are transferring courses and bearings from or to the compass rose. For plotting a point or measuring its latitude and longitude, it is always more accurate and better to use the nearest parallel of latitude and meridian or longitude, or the compass rose with the help of parallel ruler. Avoid using the compass or divider for picking up position from the chart, because using compass and divider, there is a chance that compass and divider, it may be loose, it may be tight. So there are chances that your accuracy may not be as good as when you are using a parallel ruler or scale. Okay. Now in the chart work question, usually about 50% of the marks are allotted to the plot which you make on the chart. So it is very, very important that the plot which you are making should have proper symbols. It should be labeled well. So we should be using proper symbols in chart work. So let me show you what all symbols we are using. We should use appropriate symbols to indicate various parameters like course to steer, CTS, course made good, CMG, the current or any position lines. It could be a celestial PL or a terrestrial PL. Celestial PL is which is obtained by celestial observations. What are celestial observations? Different methods with which we can use celestial bodies to calculate or find out and plot position lines. We have been using these methods right from our pre-C days. The methods are latitude by meridian altitude, also known as MARPAS, longitude by chronometer, the third one intercept, fourth one X meridian, and the fifth one Polaris or pole star observations. So these are 5 different methods with which we can calculate position lines using celestial bodies. There are many methods which are available to us to calculate and plot terrestrial PLs. Terrestrial PLs are the position lines obtained from terrestrial object. Terrestrial means object which is on the earth surface. So as simple as a bearing of a lighthouse will give you a position line. You can have a transit bearing. You can have a 3-point bearing, running fix. There are many methods with which we can calculate position lines using terrestrial objects. Then we should be using appropriate symbols to mark the DR position, estimated position, and fixes on the chart. So what are these symbols which we are using? You can see these symbols on the right hand side. A dead reckoning position is represented by just marking a line, a vertical line, and writing the time when that position was applicable. What is a dead reckoning position? A dead reckoning position is the one which is calculated only using the course steered and the log distance, okay, or the distance steamed, engine distance or log distance. Then estimated position. Estimated position is marked using a triangle with a dot in the middle, and you write down the time which is applicable for that position. What is the estimated position? If you apply the estimated current, let us say you had your course steered, you had your engine speed. So by applying that, you came to your dead reckoning position. Now you can also estimate what is the amount of current which is affecting you. What is the amount of wind which is affecting you? So if you consider the effect of current and wind, then you apply it on the dead reckoning position. What you get is the estimated position, EP. I will tell you when we go further in Chartwork in detail about EP. Then a fix is represented by a circle with a dot in the middle, and you also write down the time when that fix was obtained. Fix is a exact position or a known position of the ship. You could obtain the fix using position lines or position circle. It could be a terrestrial position line or a celestial position line. Wherever two position lines intersect, or a position line and a position circle intersect, that is where you get a fix. If you are given a fix from electronic means, GPS, GLONASS, okay, so that is represented by making a square and a dot in the middle. With this also you write down the time when this position was applicable. Then coming to the courses, whatever course you are steering, this course steered is represented on the chart with a line having a single arrow. So along with it, we also write the value. What is the value? What course we are steering? Then coming to the course made good. What is this course made good? See, you could be steering a particular course, but the vessel may not be moving in that direction. The vessel may be moving in a different direction. Why it is so? The vessel may move in a different direction because of the effect of either current or wind. Some water current may be acting on the ship's hull, pushing it in a certain direction, or wind may be acting on the ship's hull, on the windage area, applying some force, making the vessel go in a different direction. So the direction in which the vessel actually goes, you can also call it course over ground, COG. That is known as course made good. So it is represented by a line having double arrows. We also write down what is the course made good. Now,
सर सॉरी टू इंटरप्ट, एक डाउट है जो मैंने प्रैक्टिकली फेस किया था वाइल ड्रिफ्टिंग. जब हम लोग ड्रिफ्ट करते हैं, हम लोग मतलब सब कुछ अपना इंजन स्टॉप है, नाउ वी आर ड्रिफ्टिंग. So ये डाउट इसलिए आया because somebody told me, one of the senior officer told me, ऐसा मतलब the drift of a ship, the course or ground of a ship is depending upon the heading जहाँ पे हमने stop किया.
Yeah, that's right. That's very much right.
सर ये थोड़ा explain कर सकते हैं?
Okay, beta. Okay. See, what he wanted to explain to you is, let us say you have your ship here. Okay, we are going little off the topic now. Okay, it's not connected with Chartwork in any way. Let me have a blank slide. Okay. So let us say we have a ship stopped. Let us say the engine has broken down. There is a coast here, and your ship was proceeding and your engine broke down, and now you are stopped. Now, when you are stopped, you don't have any control over the heading of the ship. Okay, we have lost all our headway. Now the ship is perfectly stopped, not moving at all. Engine is not in our control. So ship is just stopped here, and let us say there is some current or wind. Okay, so let's for this purpose assume wind. So let us say there is a onshore wind. Onshore wind means the wind which is pushing us toward the shore. So we have a southerly wind. Wind is always known from the direction where it is coming from. So this arrow which I have made is basically the symbol for wind, and this will be known as southerly wind because it is coming from the south direction. Now, if this wind is pushing you, number one, there is a ship handling principle. The vessel will always stabilize with the wind on the beam. So irrespective of whatever course you were steering or whatever was the heading of the ship, when the engine stopped, it will always stabilize on a heading with the wind approximately on the beam. So if you have a southerly wind, the vessel will be stabilizing either on a easterly heading, exactly like what you are seeing on the screen, or there is a chance that it may stabilize on a westerly heading. This is how the ship is going to stabilize. Now, if you ask me why does this happen, this will come in phase 2 beta.
सर क्योंकि जो सुपर स्ट्रक्चर है जो सुपर स्ट्रक्चर नहीं जो सारा फ्रीबोर्ड है that acts as a sail.
Windage area.
Windage
Yeah,
area.
okay,
वो sail बन
okay.
जाती है सारी आगे से पीछे तक.
Yes, you are on the right track, but there is little bit more to it. There is a concept of windage point, so I'm not going deep into it. So let's hold it. This will come in phase 2. You will study in detail in phase 2. So ship stabilizes like this. Now, the drift direction of the ship, let me mark it with orange color. The drift direction, see, wind is pushing you like this. Okay. The drift direction of the ship would be anything from the direction in which the wind is pushing you up to, let us say, about 30 degrees either side. 30 degrees this side and 30 degrees this side. The ship could be drifting in any direction in this sector. Now, on what factor it depends, whether the ship will be moving exactly in the direction where wind is pushing it, or it will be moving in this direction, or it will be moving in this direction. And is there anything we can do to control it? Yes, there are a few things which can be done. This is actually checked. See, a master is supposed to know what is the drifting behavior of a ship when the engines or the ship is disabled, the engines are not working. Because you may have a danger somewhere here. Let us say you may have a shallow patch somewhere here. Now the master, if the engine is not coming, he has to do whatever he can to avoid this. Okay, so the ship should not be going in this direction. It should be going in some other direction. It will give you more time to save the ship. There could be a tug coming to assist you. So it may be arriving in 10 hours. Now, if you go in this direction, maybe 8 hours you will be running aground. So you have to make sure that the ship does not drift here. So what are all the factors on which it is decided in which direction the ship goes? See, some of the factors are in our hands. One of them is the trim of the ship. Another is the helm angle. So even when the engine is not in our control, the engine is gone, ship is disabled, you can still change the trim of the ship and you can still use the rudder angle. If you put the ship to hard a starboard or hard a port, that will make a difference of about 10 to 15 degrees of the direction in which the wind is drifting you. Or if you trim your ship by the stern or by the bow, it may make a difference in which direction you are going. So as a master, you are actually required to record all this data. There is a small publication also which is there on tankers, which says basically the drifting behavior of disabled tankers. So there is a worksheet also which is given there, a blank worksheet, which should be filled up. Why they gave it for tankers is because for tankers, this becomes all the more important because of the nature of the cargo which they are carrying. In the past, many incidents have happened where pollution incidents have occurred in these scenarios. So it is important for a master to know in which direction his ship will go and how much time is available to him before rescue can be done. So I think this is what he was trying to explain to you, beta. These are the two factors, trim and the helm, with which the drift can be changed.
सर इसमें एक क्वेश्चन है, सॉरी है सर, अभी जैसे ये शिप है, इसकी हेडिंग है 090 एंड इट्स ड्रिफ्टिंग अबाउट 300 सपोज, और ये ड्रिफ्टिंग एरिया है, अनदर शिप कम्स और वो स्टॉप करता है लाइक सपोज 180 में, सो सडनली द विंड या करंट जो भी जिसका भी स्ट्रॉन्ग इफेक्ट होगा वो एक्ट करके उसका ड्रिफ्टिंग डिसाइड करेगा कोर्स और ग्राउंड. सपोज इन दिस केस द विंड वाज इफेक्टिव, तो 30 डिग्री आइदर साइड आपने बताया सर, 270 के 30 डिग्री आइदर साइड, 000 के आइदर साइड 30 डिग्री, ओके सर,
राइट.
बट अभी ये शिप की हेडिंग 090 है,
राइट.
और दूसरा शिप एक आता है वो 180 हेड करता है, तो स्लोली सर हम ऑब्जर्व करते हैं कि वो टर्न करना चालू करता है और विंड जो होती है वो बीम पे आना, वो सेटल हो जाता है और बीम विंड पे आके ही विल आल्सो स्टार्ट ड्रिफ्टिंग, ये अपना 30 डिग्री either side of northerly heading.
Exactly. Either the ship is going to swing this way or it is going to swing this way and it is going to stabilize on a easterly or westerly heading. After this, the same thing will start to happen with the yellow ship also.
Yeah, sir. Okay, sir. Thank you. Thank you so much.
Okay. ये डिटेल में आएगा बेटा phase 2 में when you do ship handling. So I am not going into detail right now. So let's proceed. So then we have the current vector. The current is represented by a straight line with 3 arrows, triple arrow. And we can also mention the set of the current. What is the set of the current? Then next comes a position line. It could be a celestial position line or a terrestrial position line. A position line is represented with a arrow on the end. Now, depending upon what type of PL is this, you could have arrow on one end or you could have arrows on both the ends. If you have a lighthouse and you have taken a bearing, it will have arrow only in one direction. Okay. But if you have taken a celestial PL, it is not a terrestrial PL, it was a celestial PL. So in that case, you will have arrows on both the sides because a celestial PL can extend to either side. So when a position line is marked on the chart, we indicate the direction. One or two, both the directions can be written down here. And we also write down the time when this position line was applicable. Now, many a times we have to transfer a position line. When a position line is transferred, it is represented by double arrows on both the sides. So double arrows on both the sides represents a transferred PL. So these are the symbols which we use on the chart, and you can actually take a screenshot of the slide and keep it with you. Many a times people have confusions for how do we label our Chartwork plots. So these are all the symbols at one place which should be there on your plot. If you have made a plot and you have marked all these things which are mentioned, which you are seeing on this slide, it will be considered as a well labeled plot. Okay, beta, shall we proceed ahead?
Yes, sir.
Okay, now when we are solving a question, this is about second mates, we need to read the question carefully. Don't go into this. This is not for you. You have 3 questions. Read the question carefully and write the given data on the answer sheet, except the position of lights, and double check the data which you have written. If all the necessary data for working the problem is available, then you start solving it. Now, when you are solving a Chartwork question, many a times people struggle in Chartwork question simply because the data is given to us in the text form. In the question paper, we have the data in the text form, and our mind is sometimes, in fact, most of the times, not able to comprehend or understand that data well. So we need to convert that data into a diagram form. Because for a Chartwork question, see, the question has to be solved in your mind first, and then it has to be solved on the chart. If you are not able to apply your mind and find out what method is applicable here, you will not be able to make the plot on the chart. So to get the lead, there are no formulas here, only a couple of small formulas which you use for position circles or position lines. So the method with which the question is to be solved, it basically comes from the mind. So how do we get that lead from our mind? For that, number 1, follow this 1, 2, 3 procedure. In number 1, understand the question well. You should be able to understand each and everything what is given in the question. Number 2, make a rough diagram. You can make a rough diagram on your answer sheet. And when you see all the data in the form of a diagram in front of you, put everything what is given in the question in the text form in this rough diagram. And when you see this rough diagram on your answer sheet, the final plot is made on your mind. And once it is made in the mind, you make the final plot on the chart also. So as I told you, the question has to be solved in your mind first before you start solving it on the chart or answer sheet. Okay, we are required to show all the calculations in detail in the answer sheet, values of each parameter, answer obtained. If you have used any tables, please mention the tables here. All extra or unnecessary lines which are drawn on the chart during plotting should be erased, else it will confuse the examiner. Okay, now coming to the basic concepts of Chartwork, we can leave this actually, you have already done. I will be doing this in detail with the December batch and the January batch. So I'm just leaving the simpler parts. I'm just picking up the topics which you need the most for solving our present topics which are there in this module. So you know about the concept of variation and deviation. Variation is because of different locations of the magnetic north pole and the true north pole. True poles and magnetic poles are at different locations. Variation is given in the question paper, or it has to be picked up from the chart. Okay. Deviation is because of the magnetism of the ship, and deviation is given to us through a deviation card. So usually at every 10-degree heading, the deviation is provided to us. We pick up the deviation from here and we apply it. A combination of deviation and variation is what we call as the compass error. Now in Chartwork, we are required to convert compass to true courses or bearings and vice versa, true to compass bearings. So how this is done? For this, we use the method CDMVT. Compass course, apply the deviation, you get the magnetic course, you apply variation, you get the true course. To memorize it, Cadbury's dairy milk, very tasty. So just remember the CDMVT for conversion of compass to true or true to compass. True to compass is exactly reverse. Okay. Now, when you are going from true to compass, you need to pick up the deviation from the card, but the deviation card is entered with the compass heading, which is not here in this case. So we use iteration. We enter with the magnetic heading, get the deviation, get approximate compass heading, and then enter the card again a second time to get the deviation. So this was compass to true, true to compass. Beta November batch, if any of the topics, I believe all these topics are done with you. So if any of the topics you feel that you are not comfortable, you can tell me, I can go a little deeper also. Okay, then we have position line methods. We can have radar bearings. We can have transit bearing of two lights. Transit bearing means two lights are in the same line. As you can see, there are two lights here. And if you join a line, if you are seeing these two lights in the same direction, so you can join a line on the chart and this is your position line. You are somewhere on this line. That is known as transit bearing. Okay, depth contour can be used as a PL. They may give you the charted depth and you can use it as a position line. They may give you another PL, like you have a lighthouse bearing here. Wherever they intersect will be our position. Okay, this is okay. As I told you, you can have celestial position lines also. So the 5 different methods which I told you: Marpas, long bichrone, intercept, X meridian, and Polaris. So this is also okay. Okay. Now, beta, one concept which I want to cover up in detail, even with the November batch, is the course speed and current vector triangle. Now, many of the Chartwork questions, we are required to apply this concept. This is basically a triangle which involves our course steered, our course made good, and the current. So there are two things which we do with this triangle. One of the procedure is allowing for the current and wind. Another procedure is counteracting the current and the wind. So what do we mean by these two things? Now, when we say allowing for the current and wind, it basically means that the ship is steering a particular course, some current is affecting that ship, and some wind is affecting that ship. Now, how do we find out what is our course made good or course over ground? In other words, you can say you are allowing the current and wind to disturb you, and you are trying to find out what will be the resultant direction in which the ship will go. That is known as allowing the current. And what is counteracting the current? In counteracting the current, we are actually given a destination where we need to reach. It could be a pilot point. It could be the next waypoint in our passage plan. You know your present position also. So you have to steer a particular course. The course steered is not given here. You need to calculate a particular course which you need to steer so that after the current wind has affected you, you should reach on your destination. This is known as counteracting the current. So let us see them one by one. So in these questions, the data which is given to you is they will give you an initial fix, they will give you direction of the wind and the leeway angle. What is this leeway angle? Let me show you the leeway angle. If the ship is steering a particular course and the wind is affecting the course, in this case we have a northerly wind, the wind is coming like this. Now the ship may be steering 090, but the effective course will not be 090 because this wind is going to push the ship. It is applying a force on the ship and it will be pushing the ship towards the lee side, the side which is sheltered from the wind, opposite to the direction from where the wind is coming. Now the difference between these two, that is the compass course which the ship is steering, or the true course which the ship is steering, and the effective course which the ship is moving on, is known as the leeway angle. So you can see leeway means how much a vessel is pushed downwind of its intended course when navigating in the presence of wind. So let's go back. In these questions, we are given a fix. They give us the direction of wind and the leeway, and we are given any 4 items out of the following 6 data. What are these 6 data items? Compass course steered, engine speed, course made good, speed made good, and the direction and rate of current. So there are total 6 items which are there. Out of these 6, any of the 4 items are given to us. So if any of the 4 items are given, we can easily make this course, speed and current vector triangle. So it can be easily made. I'll show you how step by step how this is made. Leeway we have seen. Okay, now let's first go into how do we allow for a particular set drift and leeway. As I told you, the data given is the initial position, compass course steered. They give us information about what is the deviation, what is the variation. They give us the set and drift of the current and the wind information, that is the wind direction with leeway. What we need to calculate here is, we need to calculate what is the final position where the ship is going to land. And also with this, what will be the course made good and the distance made good. Now, what method do we use here is, you see, we are provided with compass course. So we first of all apply the deviation and variation. When we apply the deviation and variation, we get the true course steered. Now to this true course steered, we apply the leeway, which is the wind effect, to calculate the corrected true course to steer. This is also known as effective course. And then we apply the current vector and find the final position, the course made good as well as the distance made good. So let us see it in a diagrammatic form also. How do we do that? Okay, so first of all, you can see this is the data which is given to you. You have the initial position, you have the compass course, deviation, variation, engine speed, wind direction and leeway, set and drift of the current. This is the data which will be provided when you are allowing for the current and wind. And what is required? We need to find out the course made good, speed made good, the estimated position after a certain time. So how do we go about it? So let me show you all this data given on the chart and how do we apply all these things. So we have the
2 मिनट पीछे से बताएंगे सर, वो कनेक्शन लॉस्ट हो गया था सर, ये इससे लास्ट वाला सर।
डोंट वरी बेटा, जितना मैंने पिछली स्लाइड में बताया था ना, वो सारा का सारा मैं यहाँ बताने वाला हूँ दोबारा।
अच्छा, ठीक है।
ओके, You just see the data which is given on the left hand side, green data and red data, what is given, what is required. That is clear, beta? Just have a look at it.
हाँ जी सर, यहीं से मिस हुआ था, ये शायद पिछली स्लाइड का कंटिन्यू हो रहा है।
That's right, बेटा। मेरी स्लाइड यूजुअली ऐसी रहती हैं कि अगर आप एक मिस भी कर दो तो अगली स्लाइड में उसकी रेपिटेशन हो जाती है, सो डोंट वरी, just have a look here. We have the initial position, so let's plot this initial position on the chart. Let us say this is our initial position X. We also have our compass course steered. Now this compass course steered cannot be plotted on the chart straight away. On the chart we always plot the true course steered. So how do we convert the compass course to true course? We apply CDMVT. You apply the deviation which is picked up from the deviation card. You apply the variation which is given to you in the question paper, and you find the true course steered. So that you will be doing in the answer sheet. Now once you have the true course to steer, let's plot it on the chart. We have the true course steered on the chart now. You can see the true course steered. We also have the engine speed given to us. So you see we have the engine speed also given to us. Now on this course, we will have to first apply the effect of the wind. So let us see what is the direction from where the wind is coming. Okay, this is the true course steered. The wind in this question is coming, we have a southerly wind. So beta, what does southerly wind mean? Is it coming from south or going to south?
So south से आ रही है.
Right. Right, beta.
Always from.
Yes, wind always comes from. And if I say southerly current, what does that mean? Current is taking us south?
Coming.
Current is coming.
तो south को जा रहा है current.
Right. So wind always comes from and current always goes to. Okay. You can write this down in your notebooks also. Always remember this at the back of your mind. Wind always comes from and current always goes to. So a southerly wind means the wind is coming from south. So let's show the wind here by an arrow. So this is how the wind is affecting us. Now, if the wind is affecting us like this, how would the effective course of the ship be? हमारा कोर्स बेटा बताओ 090 से कम होगा या 090 से ज्यादा होगा? इफेक्टिव कोर्स जो होगा हमारा
सर कम होगा सर.
Very good. It will be less than 090 because the wind is pushing us from the starboard beam. So effective course यहाँ पे प्लॉट करने के लिए अब हमें leeway angle will be given to us. You see it is there in the data which is given. We have to apply this leeway angle in the direction in which the wind is pushing us. So let's apply. I have applied the leeway angle here. Okay, this is the leeway angle. Now, after applying the leeway angle, I will have the effective course. So you see this blue color line which we are seeing is our effective course now. This effective course is represented with a single arrow. I showed you the course steered is represented with a single arrow. So we have marked it with a single arrow. So this is how we apply the effect of the wind. Now let's apply the effect of the current also. They have given us the set and drift of the current. Set means the direction in which the current is going, and drift means the distance which the current has pushed us. Okay, or the distance which the current is pushing.
ये तो सर ठीक है, of course साउथ से आ रही है, ऊपर हो गया, definitely कम होगी. सर ये कितने डिग्री कम होगी ये हम कैसे डिसाइड करते हैं सर, just for understanding?
Okay, बेटा as far as Chartwork questions are concerned, ये आपको नहीं निकालना पड़ेगा, ये दो दिया होगा. Okay, it will be given to you. Okay, so you just pick up the value from the data given and you apply it. So Chartwork question is done. अब आते हैं कि practically if you want to see ये लीवे एंगल कैसे मेजर किया जाता है. I'll show you a small video, the 5 minutes video, so you will understand how this leeway angle is calculated. Okay, let me finish this first, then I'll show you.
जी सर.
Okay, so let's apply the current now. Set is the direction in which the current is taking you, and drift is the distance the current is taking us. So let's use the red color for the current. Now the current is applied on this blue color vector. Wherever the blue color vector is ending, how do we know where this is ending? That is decided by the engine speed. Usually this triangle which we are making, the course speed and current triangle, is made for 1 hour. So you cut this effective course or course steered by the distance which you have covered, engine distance of 1 hour, that will be equal to your engine speed. So once you cut it, you get this point Y, where this vector is ending. You apply the current on this point now. So we have applied the current. The current is acting in this particular direction. The length of this current vector, the red vector, is what is the drift mentioned to us in the question. So current is represented by 3 arrows. So let's mark 3 arrows here. We have the current vector now. Now once you apply the current vector, you reach to your destination. This position where the current vector is ending is your final position or estimated position. You can call it Z. You see EP written here. EP means this is the estimated position. Now if you join X with Z, that is the initial position with your final position, which vector we will be getting?
Course made good, speed made good, 2 arrows.
Very good. This will be the course made good vector, and if you measure the length of this vector, that will give you the speed made good. If this is a 1 hour triangle, then the length of this vector will be the distance covered by the ship or made good by the ship in 1 hour, which is the speed made good. So this is how we allow for current and wind. So अब बेटा इसमें कोई doubt अगर आपको आ रहा है or you want me to repeat the animation once again.